Hello class, this is Mr. Sorry. We are going over homework 5 in unit 2. I got an email from a few of you saying that you were struggling with it, so I'd be glad to go over it with you guys and talk about the answers and where they came from. So, when you are working on something like this, it is important to get out the pages of the guided notes packet. All of the reference pages from 2.4, so we've got the properties of equality, segment proofs reference, as well as the angle proofs reference. And then it would also be a good idea to have out the 2.5 notes that we all or in part filled out together. So those 3 angle proofs and those 3 segment proofs. So when it comes to completing the homework, it says use the segment addition postulate to write 3 equations using the diagram below. So to come up with these equations, you basically have to use the segment addition postulate, which, recall, the segment addition postulate states that if A, B, and C are collinear points and A and B is between A and C, then you can take part plus part and set it equal to whole. So AB plus BC equals AC. So when we're doing the homework, you have lots of different options here. We could do, if we want PR to be the whole, we could do PQ plus QR equals PR. So that could be number 1. Well, let's say we do Q to T. We could do QS plus ST equals QT. Or we could do RS plus ST equals RT. There's lots of different options here. But hopefully that helps you come up with the first few. Let's get down to this correct homework. So there are some examples from those. And let's get rid of all these pages. Okay. So next, okay. So here we go. So complete the proofs below by filling in the missing reasons. You may pick from the bank of reasons printed above each proof. So when you're doing these, if you don't yet know what these properties are, it's really important that you, at the start of the problem, identify what they're all used for. So you have the substitution property. Recall the substitution property is a property that if A equals B, then A may be replaced by B in any expression, or B can be replaced by A in any expression. So that's what the substitution property is. Then you have the transitive property. That was the one that was a lot like the substitution, but not exactly like it. That's the one that goes, if A equals B and B equals C, then A equals C. It's kind of like the law of syllogism that we used. So that's the transitive property. Then we have definition of a midpoint. Remember, the definition of a midpoint, that's from the segment proofs reference. Definition of a midpoint states that the midpoint of a segment divides the segment into 2 equal or congruent parts. So that's what definition of a midpoint tells us. Given, we know givens are used when we make a statement that the reason why we can make that statement was because it was given to us right here. Definition of congruence. Think about what definition of congruence is. Definition of congruence is what allows us to go back and forth between a congruent symbol and an equal sign. Equal sign to congruent symbol. When you're jumping from AB is congruent to CD to AB equals CD, it's definition of congruence. You can also work from the equal sign to the congruent symbol. So that's what definition of congruence allows us to do. And then lastly, the symmetric property. The symmetric property is the one that turns around an equation. So there's no symmetric property right here. If A equals B, then B equals A. So that is what the symmetric property allows us to do. So, continuing on into the homework. So, So if K is the midpoint of JL, so we're looking at our givens. If K is the midpoint of JL, and M is the midpoint of LN, and JK equals MN. So we should probably make some markings on here. So K is the midpoint of JL. Okay. So K is the midpoint, so we can say that JK is congruent to KL. And then M is the midpoint of LN. So M is the midpoint of LN, okay? So that means LM is congruent to MN. And then we also know JK is congruent to MN. And we want to prove that KL is congruent to LN. Okay, so let's see what this statement, for number one, let's see where that statement came from. So, K is the midpoint of JL, and M is the midpoint of LN. What allowed us to say that? What was the reason? And remember, we use one of these reasons up here to say what allows us to say that. Well, notice that these two statements came from the givens right here. So the reason here is given. So given for the first reason. And let me go ahead. Okay. So now that we've said that those were given, what allows us to say that JK equals KL? Well, JK equals KL and LM equals MN. What allows us to conclude that based on what we've established so far? Only based on what was up above it in number one. So we were given that K is the midpoint of JL, and then we concluded that JK equaled KL. We're able to conclude that by the definition of a midpoint, because that's what a midpoint tells us. Remember, the definition of a midpoint we just reviewed states that if some point is the midpoint of a segment, it divides that segment into two congruent parts. So that's what allows us to say JK equals KL. Okay, so that was definition of a midpoint. So here we go. Definition of a midpoint. Okay, so number three. So what allows us to say that JK equals MN? Well, it doesn't have anything to do with this, and oh, look at that. That was given as well. JK equals MN, JK equals MN. So the reason that we're able to make the statement for number three was because it was given. So number three, given. Okay, number four. MN equals KL and LM equals MN. MN equals KL and LM equals MN. So notice MN equals KL and LM equals MN. So notice, remember, and we're just using the information, the statements above it. So how could we possibly create this statement from this information above here? What must have happened? Well, I'm going to compare number 4 and number 2, because it seems like we did something number 2 to make number 4. Because if you look at number 2 and number 4, what's changed? So KL, and you still have KL right there. LM, and you still have LM right there. MN, and you still have MN right there. So those haven't changed at all from 2 to 4. But JK turned into MN. What could we have done based on this that allows us MN to turn into JK? Well, since we said that JK equaled MN, we substituted in MN in for JK right there. And it became MN equals KL, LM equals MN. So that, number 4, should be the substitution property. Substitution property. Okay, so we did that by substitution property. Now, LM equals KL. LM equals KL. What allows us to say that? LM equals KL. Well, notice we have that MN equals KL and MN equals LM. So when you have the same thing equals two separate things, so like when you have MN equaling something and then MN equaling something else, it's the transitive property that allows you to say that those two equal each other. So LM equals KL, that is the transitive property. Transitive property. It's almost like double substitution, you can think of it as. So, next. So, number 5 was transitive property. All right, number 6. KL equals LM. What allows us to go from 5 to 6? What could possibly... And remember, we want to be crossing these out as we go. So we use the two givens. We use definition midpoint. We use transitive. We use substitution. So all we have left is definition congruence and symmetric property. So what allows us to go from 5 to 6? Would that be symmetric property or definition congruence? Well, recall symmetric property is what allows you to reverse an equation, to switch it around, which that's exactly what happened from 5 to 6. So 6 would be symmetric property. Symmetric property. And then for number 7, when we go from an equal sign to a congruence, that is the definition of congruence right there. So that's number 7. And there we go. So that is numbers 1 through 4 on homework 5. Check out my next video for number 5 and beyond.